Hello everyone, welcome you all. So in this video we are going to discuss what is meant by multiplexer and a 2:1 multiplexer we will be going to design. So first we will try to know what is meant by multiplexer and what is the use of it. So basically a multiplexer is a device which selects one input out of many number of lines which are present. So a general block diagram for this which can be drawn in this way. Okay, so a block is there for which there are many inputs 1 2 3 and 4 in this case, and there will be some select lines, and depending on the select line it will be selecting one input and it will be passing to the output. So out of this 4 it will be selecting one at a time. So it is basically a switch. Okay, so there are 3 inputs, and if it is a switch then it will select one input and it will pass it to the output. Either this will connect to the let us say 1 2 and 3. So either it will connect to the first one or second one or third one. So like this, a multiplexer is basically a switch which selects one input and passes it to the output at a time. So we can call the multiplexer with the name data selector. So these are the data lines which are coming to a system. So it will select one data line at a time. So that's why it is also called as data selector. So here is the formula for multiplexer implementation. So that is 2 to the power m equal to n. So here m is the number of select lines and n is the number of output lines. So in case of 2:1 mux, the number of output lines are so n equal to 1 is the okay, so this is for demux, right? So 2 to the power n, that is, this is the formula where we are using a 2:1 mux, means 2 to the power 1, which is equal to 2. So number of select lines will be 1 here. So this is for demux, sorry, and this is the formula for mux, where is 2 to the power n number of select lines. So if it is for 2 to the power 2 means n equal to 2, we need 2 select lines. If it is 8:1 mux, then 2 to the power 3, so 3 select lines are needed. So like this we can calculate the number of select lines required for the particular mux with the help of formula 2 to the power n. Okay, so where n is the number of select lines. Okay, so now coming to a block diagram, particular block diagram. So a 2 to the power 1 mux will be having two inputs, I0 and I1, a select line 1, so that is denoted as S0, and 1 will be the output. Okay, so that is denoted by Y. So this is a block diagram. So in particular, how it should be drawn, the particular figure is like this. So there are two parallel lines, second line will be shorter, so like this we will be joining, and I0 and I1 will be same as it is, and S0 and Y is also same. So this is the actual representation and this is the block diagram representation. So this is more particular and you need to draw this in the exam. Now the truth table for the 2:1 mux is S0 and Y. So S0 is the select line. If S0 is 0, so depending on the S0 value it will be selecting I0 or I1. So if S0 is 0, then it will select I0, and if it is 0 it will be selecting I0, and if it is equal to 1 it will select I1. Okay, so this is the working here. So S0 is 0 means output will be I0, S0 is 1 means output will be I1. So with the help of this table I can write the output equation Y equal to S0 bar into I0 plus S0 into I1. Okay, so S0 bar into I0 plus S1 into I1. Now the circuit diagram for this, how we can draw the circuit diagram. So see, the output equation is S0 bar into I0 plus S0 into I1. So there are two AND gates because there are two multiplication terms here, and OR gate, that is addition, is there, so we need to use one OR gate. Okay, so what are the terms? I0 and S0 we are needing, so we will use two AND gates here, and to get the complement of S0, that is S0 bar, we are using the NOT gate here. So for first AND gate, S0 bar and I0 will be input. So I0 I will connect here and I1 I will connect here. So S0 bar is coming here. So this is the S0 bar. So I0 into S0 bar will be multiplied here, and for the second gate S0 and I1. So this is I1 and the S1 is S0 is coming here. So this will be multiplied and both are given to the OR gate so that they can add. So output equation S0 bar into I0 plus S0 into I1 will be getting. So like this we can implement a 2:1 mux with the help of two AND gates and a OR gate. So hope you understood or liked the video. So if it is informative a little bit, so please guys hit the like button, and if you have not subscribed the channel, please guys do subscribe. Thank you, thanks for watching.